You'll want to look right here. Starting to have some issues. So we did have a little something going on there. 101,000 miles on this perfectly running engine. This is the LM2 3.0 Duramax diesel. This is a 2020. So if you followed along on my videos, you know the 2020 is well known for the timing chain issue, which is located here in the back of the engine. We're going to do a complete teardown of this engine. Like I said, this was running. Now you're probably wondering, well, why do we have a perfectly running engine? Why not just repair it? Well, let me tell you, in this case, the engine was cheaper to replace versus repair. So this core itself right here is $5,000. However, to buy the engine, it's anywhere from $3,000 to $6,000 plus labor. Obviously, you could see the route that this vehicle owner went. They wanted to go with a whole new engine, and I don't blame them. So what we get to do is tear down this engine. We're going to see how much wear is actually in here after 100,000 miles. I highly suggest you bookmark this video, share it, because I will be going over every single leak point. We're going to talk about how to remove each and every item. Crank pulley is held on with some 15mm bolts. The good news here is there's no special puller required to get that off. It just slides right off just like that. Now, as you can see, we already have a little bit of indicators that there was some oil leakage here. Now, let me talk about this front plug. This is typically where the leakage comes from whenever you have an engine oil leak on a 3.0 Duramax diesel. What happens is it starts to drip down here, goes down the front cover, and it makes it look like there's a front cover because it's really hard to see this. And then so a lot of people go in and replace the oil pan when it's not really the oil pan. It's actually just this plug. And that'll be the same thing for this front cover. Let's go ahead and rip off this front cover. These are 8mm bolts. And we just want to pry this off. And then after that, we're going to go into the water pump, which again is 8mm bolts. When looking at the water pump, let me show you where the common leak locations are. You'll want to look right here for any kind of signs of leakage. You can see there's a little bit of crusties right there. That's an indicator. That's a very smidge amount of coolant coming out there. So over time, this will actually get worse, and that's where you're going to see the coolant leak if you have a water pump leaking. But this one seems to be good. Luckily, the new engine came with one, so they don't need to swap this over. But in all reality, if I'm replacing the engine and it didn't come with a water pump, I'm putting a new one on there. So let's go ahead and get this off. I have a tray that I'll set these bolts in, but we're gonna go ahead and just zip these off real quick. And we'll do the same for the water pump since we're here. Did you notice how that bolt was longer right there? That was up at the top. Look at that, another long one. So let's go ahead and compare. The two long ones are at 12 o'clock, 6 o'clock. The other bolts are all the same. Anytime you're prying on any surface, you want to make sure you don't damage the actual surface where the sealant will be. And that is the engine block, obviously. So if you damage that, you're in bad shape. These are the dowel pins. These help guide this on. There is a special tool required to install the new one. So if you were installing a new one, use a special tool. Goes on there. Go ahead and just guide it into place. But for now, we're going to go ahead and start prying this off so we can get it off. It's going to be a bit of a chore, getting the right angle and whatnot, but we'll see what we can get. I'm using this as a leverage point, this as a leverage point. But here's our front cover. You can see there's really no signs of any issues with any of the sealant anywhere. So we're going to go ahead and just drop that down like that. Now our water pump, same thing. We're going to go ahead and just pull this off. Glad I put that bucket there. And I'm just gently prying on this. We just want to free it up. And there we go. See, it's just got a regular gasket that does come with the water pump itself when you buy a new one. There's also an O-ring included in a lot of the kits, and that's for that pipe on the back right there, which I can spin this around so we can see that a little bit better. But this pipe can come off, and you can see our coolant temp sensor right there. And we'll get into the temp sensors in just a second here. With the front cover off, you can scrape this off lightly. Make sure you do not put any gouges or cause any further issues with this, or else it will not seal up. Like I said, there is a special tool needed. Let's go and take off this block plug. It is a 10mm Allen. With this being on the engine or on the cherry picker, this might be a little interesting. I'll just go ahead and pop that loose like that. Not bad at all. So you can see how much oil was right there, right at the front. This was going to leak in the near future. You can tell by just how much oil is on there. So what you want to do is clean that up. It'd be preferred if you replace it, but you can clean that up. And I like to use either thread sealant, the GM thread sealant, that's just the PTFE thread sealant, or some GMS RTV. So clean up these threads so it can seal properly. Torque specs are there. Now, there are block plugs in the back of this engine as well, and we're going to get into that. There's two different sizes. So I'm going to go ahead, we're just going to leave that out actually. So now we can go ahead and start to bolt up the engine front cover, or the engine bracket. So this is a special tool by GM to help us with the engine on the engine stand. So now that threads and all crusty. Right, all right, so that bracket is nice and tight. And as you can see, I didn't fully have to remove all that stuff, but again, this video is super thorough. We're going into everything. The water pump is still accessible. That block plug is not accessible, so that would have messed us up. This is the actual GM special tool, super beefy. This is going to allow us to stick it on the engine stand, which we'll do right now. All right, this is the moment of truth to see if this engine stand will hold this engine. I really hope so, because those head bolts are on really tight and I have to really pry on it. Hey, that's a great sign right there. I'm very happy. Actually didn't flex or anything. I really expected this to bend down, but looks like we are good to go. Now you're probably wondering about that engine bracket right there. So this is a GM special tool as well, and this is made specifically for the 3.0 Duramax diesel. I feel like this is absolutely critical to have, as is this block right here, because look at this engine stand. This doesn't look sketchy at all, outside of this being a super cheap engine stand that I got off of Amazon. Seeing it not flex, I'm pretty stoked on that, but we'll see once we start to rotate this over. It's going to get crazy because this is dangerous. But for the sake of the video, here we are. We have it on the engine stand. I'm going to go ahead and remove the cherry picker, get this out of my way, and then we're going to go over the whole outside of this engine and go over all the sensors and all the common leak points, and we're going to look into those intake valves, because I know we all want to know, what do those intake valves look like. And before anybody asks, I hate answering questions before people ask, because I do really enjoy questions. So please post up questions. But this engine did not have a catch can ever in its life. Now that we've got the engine cherry picker out of the way, we can go over the full engine right here. This is the rear of the engine. I know it's weird that you have to mount it from the front, but that's because the timing chain and all the components are in the back of the engine. But let's start back here and just discuss everything that we see. Now this is the water pump inlet, and as you can see, that is engine coolant temp sensor 1 right there. Now, engine coolant temp 2 and 3 are actually located on the heater inlet and outlet, so those aren't part of the engine. Engine coolant temperature 4 is right here above the coolant control valve, which we're actually going to grab the coolant control valve and set it in place so we can see that. So this is engine coolant temp sensor 4 right there. Engine coolant temp sensor 5 is located just above the block heater. The block heater is this guy right here. Now this is what you're plugging into the wall with the cord. Let me go over here. I actually have a cord so I can show you. Remember this cord? This is the one. When you plug it into the wall, it's actually plugged into that block heater, and that's what warms up the coolant in the engine block. Rolling around back to the right side of the engine. Now we're going to go over, here's your oil filter. I'm sure you're familiar with that. Oil pressure sensor goes right here. It's gone from this one because it went onto the other engine. Oil temperature sensor is right there. Here is our crankshaft position sensor located right there. And we have our timing chain tensioner here. And this is the cam position sensor that's going to read off the reluctor, which we will see shortly. This is your engine oil pan, the lower, and this is the upper oil pan or lower crankcase, depending on how you want to word it. Now, since I said that we had all the maintenance records of this, I do know that at 50,000 miles, this vehicle had an oil pressure issue, and I believe the oil pressure solenoid was replaced, which means the oil pan had to come off, and you can see this GM sealant. It requires just a 4mm bead on the engine oil pan. We're going to remove that engine oil pan a little bit later. we'll remove the flex plate and the rear engine cover. This is the access to the injection pump, which we're actually going to use the tool. And I'm going to show you how to remove this injection pump without messing up the timing. So we'll pull off the injection pump. This is what provides the pressurized fuel to the rail, which the rail is not shown here, but I have one on the bench, so we can go ahead and look at that. This is your engine oil cooler itself. Coolant control valve goes right here. Let me grab that. This is the engine coolant control valve. As you can see, I'm setting it in place. There's a lot of hoses there. This is probably the most common failure point of this Duramax diesel for all generations, up till the current ones. So as you can see, that is where the coolant temperature sensor is that we talked about before. That's number 4, and that's number 5 over there. All right, so the coolant control valve, what is this doing? It's opening and closing with these motors that are located on there. And as you can see, I'm covering up that one. But the LM2 has 3 motors, and it controls various positions in order to flow the coolant. Now, you can see with the engine oil cooler right here, you'll see your engine oil temps climb up if you have like a Banks iDash gauge, which I highly recommend because then you can see all of your temperatures. But you'll see that the oil temperature will go up, and then suddenly it will come down. Well, that's simply because the engine coolant control valve actually opened up and was flowing coolant through the actual cooler itself to allow for the engine oil to cool down. Pretty neat, huh? This is our block heater right here. This is a 26mm socket. To take this off, we're gonna go ahead and take this off just to look and see what it actually looks like. Looks like it had a little bit of a leakage there, didn't it? See right here on the bottom side? So this truck may have had a super slow leak and didn't know where it was coming from. This is not a typical leak location. So that's actually pretty cool that we got a chance to see this as another potential leak point for you to look at. No signs of corrosion, anything outside of just that it seemed like it wasn't that tight. And as you can see, ECT sensor number 5 is right above it. All right, so since we went over all the temperature sensors, what about this one? I skipped this one, right? That's what you're thinking, because we have 5 coolant temperature sensors. This one's actually for the cylinder head, and it's not part of the ECT engine coolant temperature 1, 2, 3, 4, 5. It is its own temperature sensor called cylinder head temperature sensor. So this is our water pump inlet. Remember, I talked about that a little bit earlier. So we can go ahead and actually pull this off now, and you can see that O-ring that I was talking about. Now, this is why you have the longer bolts. Remember those bolts, 12 o'clock, 6 o'clock? Those are them. They go all the way through, and that pulls this through. I have never seen one of these O-rings leak, so that's a great sign. But just so you know, that's where that is. All right, so we're missing a lot of stuff on the top of the engine. So let me just go over real briefly how this is. There is a foam cover across the top of the engine here. Then there is a bracket. Then the charge air cooler itself. So the way that this works is air actually comes out of the turbocharger, rolls around through here, and it cools it off through here, and then it exits through here. So the reason I'm saying that is this is charge air cooler temperature sensor 1, charge air cooler temperature sensor 2. So 1 is in, 2 is out. This does have coolant flowing through it. It is a separate cooling system in itself. Common leak points for this charge air cooler is typically right here. You'll see some coolant dripping there. You'll see some coolant dripping down through here. So pay close attention if you have a loss of coolant. That is the small reservoir at the front of the engine. The one at the back of the engine, the larger coolant reservoir, that's for your water pump, and that's for your whole engine itself. We'll go ahead and set this aside. So this engine didn't come with a fuel rail for me because the engine itself actually came with the wrong fuel rail, so it had to be swapped. So luckily I had this from a prior video that I did, but this is what the fuel rail looks like. You got your fuel pressure regulator here, and you have your fuel pressure sensor here. And this just slips over these studs right here. So we're gonna get this out of the way because I know you're probably dying to see inside those intake valves. Let's do that right now. 100,000 miles, intake valves, no catch can. What do we see? We got a little bit of buildup there. Got a little bit of buildup there. Now I'm gonna go over each one because in the back, it's actually the cleanest spot, believe it or not. So you can go ahead and leave in the comments why you think that is. But obviously we don't have an intake manifold on here to see, but I will tell you the intake manifolds do get cracks in them at the seams, and they will cause airflow issues. So here we are getting close. We are at number 5 right now. Go and take a closer look there. Now number 6. If we can get in there, of course not. All right, I had to flip the camera over so we could see in there better. See how much cleaner the back cylinders are? So I wonder if we're gonna see any difference on the back cylinders. I know when I posted up asking people what kind of questions they had or what they really wanted to see on this engine teardown, specifically these back cylinders, are there any signs of heat, additional heat or anything like that? Well, right now our early signs are the oil does not make it all the way back there. Basically stays in these front cylinders. So we're gonna go ahead and start working on the top now. All right, these are our fuel injectors. Now these are specific to the cylinders that they're in. It has to be programmed through the ECM in order to swap it out. So if you get a new one, there is a code on here. You do need a scan tool to do that. In order to remove these, there's these lock tabs right here. And you just push it up and that allows you to push this clip down right here and it comes right up. So a common problem with these is when you pull this off, if you look to see if there's any dust inside there, it's like a rust looking dust. Basically, that's a connection issue at the injector. So if you have injector related issues, you really need to take a look at the connector itself. Now this is part of a whole assembly. It's this guy right here, and that will stretch all the way back and hit all 6. I do have this tool right here, which will allow me to slide it in and then we can see what kind of pin tension. This is actually really good pin tension right there. So you can see that it's not even coming loose. So number 1 is good. Number 2 is a common failure point. So we're gonna go ahead and pay close attention to that one. Let's go ahead and get that off. All right, number 2, I do not see any dust in there like I was talking about. We'll go ahead and see the pin tension. Oh, this is really good. No, this harness is actually in really good shape. You could see a possible rub point right there, but this one actually doesn't show any indications of that. This harness is in great shape. I would not mind reusing this if I tested each and every connector. However, a new one is typically best. Now let's go ahead and get the rest of these off, get this harness out of the way so we can talk about the fuel return line and how to disconnect this. All right, now to pop these off, you can just slide it up like that and it comes off. A tool that I like to use for this is actually a hose pick tool, because then you can just get under it, pop it up just like that. Be careful not to poke yourself in the eye, poke yourself in the arm. Safety first, right? All right, with that harness out of the way, so now you can see these return lines, and I just pushed on this, but the way to remove these is you actually push on this, push on that, I see how it's popped out. You actually push on this and then you lift it up. So the O-ring underneath is one-time use. Honestly, if you're gonna go into these fuel injectors, I highly recommend you get a whole new harness. As you can see, it popped right off. There is an O-ring on there. They do say it's one-time use. Honestly, these are so easy to break. Get a new one. You don't want to have to go back in here, but that's it. You just push this in. You'll see it when it gets to the point where it's pushed in. I'm also pushing down to try to relieve some stress. There it goes. Once that's in, then we can go ahead and pry up. Like I said, just get a new one. There we go. See, we're okay. We're not breaking any, but I'm going to go ahead and pull off the rest of these, but hopefully you can understand. Push that in. Super easy to get these off. Broke that one because I got a little bit too anxious on removing it. But once I get it pushed in, I'm pulling up to allow that metal retainer to actually stay put in there, which I rushed on this one, but you can see that's all taken care of. And this is our return line. So this actually goes down to our injection pump. This is our return line that will go back out to the tank. So we can go ahead and remove. We're going to leave this on actually. Let's stick with just trying to get to the camshaft cover. So now these are all broken loose. So in order to get these, it's a 17mm wrench. But in my case, they're all loosened up for me because the rail had to come off. So this is lucky for me. These are one-time use lines. I know a lot of people reuse them without issue, but I'm just saying, These are supposed to be one-time use lines because they're compression fit and they squeeze into place and you don't want any leakage on there. So we're gonna go ahead and get these out of the way. And as you can see, it's starting to open up. Piece by piece, we'll get there. Fuel injectors, 1, 2, 3, 4, 5, 6. That's how it's numbered from the front to the back. So if you ever remove these, make sure they go back in the exact same position. Otherwise, it's not going to run very well. These are the codes that are stored in the ECM. Now, if you go ahead and lose track of the numbers, there's actually numbers located on the side of the charge air cooler right here. So that will tell you what's in there, but that's only in stock form if they're in the correct order. So make sure you check on that. Now, if you get a brand new engine, that sticker actually comes right here. So you need to record that because the new engine comes with all new fuel injectors. And that's why it's a huge deal on the new one, because you get all new fuel injectors, you get new injection pump, you get new engine oil cooler, you got the lines that are all set up. A brand new engine is a solid deal in my opinion. We're going to remove the lines as a complete assembly, so we'll pull off this 10mm here, we'll pull off these 8s, we need to get to that 10mm back there, and then the 19mm wrench will be used to remove that. We do have a tool to remove these lines, so I'll go ahead and show those, but we'll just get all this stuff out of the way so then we have a better visual of the injection pump. This is an HP5. I'm going to go into the common failures with this pump, so we'll get into that. We'll pull off these glow plugs after that. But for right now, let's get these lines off real quick. I'm going to try to keep these together as an assembly if at all possible, so we will be easier to keep track of. Again, these lines are one-time use. All of the fuel lines are one-time use if they have a tight fitting like this. So I'm just going to loosen these up. Glad that bucket's there. Should probably grab some towels. Smells like good fuel too, so that's a good sign. Oh. So I don't have it with me, but typically I use a metal variation of these and that works much better. I bought it off of Amazon. It works really well, but you just spill it everywhere. But you just push this on this way and it disengages these tabs right there, and that will allow you to pull it off. So we're just making a mess over here, but that's what it's for, right? Like I said, you just set this on there and I'm pushing this towards me while pushing the line into it. Did you see it click kind of in place? That means it just unlatched those lock tabs. So then be sure to pull your tool off. I've lost several of these because I left it on there. I'm gonna go ahead and set that up there, grab my towel, and we're gonna take this as a complete unit. Just let that drain like that, and we'll set this. I'll actually bring this over to this engine stand right there. Let that drain itself out over there. All right, so now we've got much better visual of everything. You can see the bracket. This is our glow plug harness. So if you're going to do glow plugs, you'll need to pull off this connector. And there's really no special trick to it. You may be able to just pull it off, but they're just pushed into place. That's hard. So I'm going to show with a pry bar. Because I've got good angles, but these are going to be very brittle with this amount of miles. A lot of heat cycles, but you see how it just pulled straight up. There's no lock tab to worry about. The glow plugs are one-time use, so if you pull those out, that's it. So we're going to go ahead and just pull off all of these to get this out of the way. And as you can see, I'm just kind of wiggling like that. It's coming right off. So obviously you're going to be working from the top of the vehicle, and you can grab a pair of pliers, which I'll do that just to show you, since that's what we're doing, right? We're showing everything. Let's see here. We'll just grab these guys. Not really the right tool for the job, but let me just show you. You can grab it lightly and just pull up like that. That's it. So that'll probably be your best bet if you don't have any access. So there we go. There's our glow plugs. Like I said, one-time use. And these are common to break, so be sure that you have a replacement harness if you're able to. Now let's go ahead and pull these off. All right, these are 10 millimeter, and these are torqued to specs. You cannot reuse these. These are very delicate. If you drop them, that's it, they're done. These are, it's possible, it's not super common, but it's possible for the tips to actually fall off inside the cylinder, which will destroy the engine completely. So you can see this one has a little bit of discoloration on it like that. Go ahead and comment what you believe is coming through the system with that. I'm going to continue pulling all these out. Like I said, replace these. These are one-time use. Now, when you go to put in a brand new one, before you do, there's actually a reaming tool that you have to use to clean these out, and that will make sure that these go in perfectly smooth and they're not going to get all stuck and gunked up. Let's go ahead, pull these off. So number 2 is well known for glow plugs going out, and you can see, look at the amount of crap is on there. That was number 2. See what number 3 looks like. Number 3 is just as bad, I believe. Well, maybe slightly less, but still pretty bad. Let's go through here. That may be coolant. That could be. There's a lot of variables on that. Oh, this one has barely any. So when are the glow plugs used? That's during cold start. It helps get the engine up to temperature because there are no spark plugs inside a diesel engine. So these work to create heat in the cylinder. The engine fires whenever it has enough heat in there when fuel is injected. So these will bring up the temperature very fast. You do not want to mix these up with different engine models like the LZ0. Make sure you have the right one. Even when you buy a brand new glow plug, make sure you look at it. Compare your new glow plug to your old glow plug. You do not want to make a mistake. They could be packaged wrong. Let's go ahead and get these injectors off. Like I said, numbered 1 through 6. In my case, it doesn't matter because it doesn't matter which ones they go back on. Once we get those off, let's go over the valve cover and engine oil consumption. These are 13 millimeter bolts. These do need to be torqued down and specifically, and then the orientation of this hold down is like so. But we're gonna go ahead and pull these all out like this. When removing these, what I do is just twist. There is a special tool, which I do not have, to help you remove these. But I start off with a twist. That one's tight. And if you could twist them by hand, that's a fantastic sign. If it's not twistable by hand, then we got buildup on them. So just the motion of twisting them back and forth. You could also connect a fuel line, which I'll do to show you right now. And that will allow you to get a better twisting motion. Like this, and that just creates a little bit of leverage. So from there, I'm pulling up. But I think what we're going to do is get a pry bar underneath it. This is where that tool would be handy, which I did not care to bring with me. There we go. Got that one popped up, and we'll continue to do that for the rest of them. I also want to point out that working inside the vehicle before doing this, there's no issue with blowing these out a little bit because there could be dirt buildup in there. You can see a little bit of dirt buildup inside there. But when you pull these up, any dirt that's in there is likely to fall into the cylinder. There's really not much you could do about it except for do the best that you can to get the dirt out. So if we pull out the cylinder head and we see dirt in there, It's likely because I dropped it. Yeah, I'm just gently prying up while twisting it. That allows these to come up. You can see the dirt that I'm talking about. See how it's right there? Look at the rest of these. There we go. 2 more. We'll look at these individually when we pull them out to see what kind of crap and soot buildup we have on each one. See if we can see if there was a leaking injector at some point or... There we go. Down to the last one. Looks like I won that battle. Let's go ahead and take these out one by one. Set that back there. Number 1. Whew. Look at that. Look how clean that tip is. We'll see as we continue on what the others look like. Not much there. Very clean tip. This one's got buildup there on the top. Now, buildup up there does not matter as the injectors actually spray from the holes through here. You cannot mix an LM2 injector with an LZ0 injector, just so you know, in case that ever crosses your mind. That one, bunch of soot and crap built up on it, but nothing to be worried about. That one's looking the same, just a basic buildup. All right, so the only one, this number 1 is extremely wet. Now that could be because that was the first one that we disconnected the fuel return line on, and therefore it leaked down into it. Or this could be an indicator that that cylinder is over fueling, which we'll be able to check that out when we pull this engine apart further. This is our camshaft cover right here. Now let's talk oil consumption real quick, because that is a huge topic on the LM2. Now in the early years, 2020, 21, there was a bulletin that came out that there was actually an issue with the camshaft covers themselves. So you followed this number. I do have a video on that. And basically inside it starts to leak, and it will allow engine oil consumption, excessive engine oil consumption. But let me tell you, that is applicable to all years of the 3.0 Duramax diesel, the LM2 and the LZ0. Now, while that bulletin only applies specifically to those numbers, here is our PCV system. It's built into this right here. And this is just a diaphragm with a spring. This will leak internally, which will blow oil out through here. Now, the hose that goes from here to the turbo and then through the charge air cooler, that will be full of oil. So any year 3.0 Duramax diesel can have an oil consumption issue based off of this failing itself. So don't follow just specifically, it only applies to the ones under that bulletin. Nope, 2020 all the way up to the 2024s, I know for sure have potential to have a leakage here. I've seen it. So that's my my personal experience, which you'll see throughout this whole video. This is our pressure sensor. These often go bad because they get kind of gummed up inside, and access to this is a little tough. So that's roughly a 3-hour job, but these will go bad as well. And I don't know if that's an early indicator that we have a situation here. My experience has shown me that once you replace the sensor, you really don't have like an oil consumption issue, but time will tell on that. So let's go and take off all these 8mm bolts and remove this camshaft cover. Before we do, look at this. We've got signs of engine oil leakage right here on the back side of it. So this one was getting close to starting to get an oil leak that was going to drip down all the way down here. And let me tell you, those are tough to diagnose because you can't see anything back here. So this one was getting close there, but we're good to go. No issues there. It will not pop right off. These are actually stuck on very well, and it's going to need a pry bar to lift it up. So there's silicone back here on this back corner. A lot of people miss that when they replace the camshaft cover. They don't seem to put the silicone back here because you can't see it if you're doing it inside the vehicle without the cab off, but I just want to point that out. Torque specs on the cam cover are inside. This one is on really well. So again, when prying, you don't want to damage any of the sealing surface area. Listen to that thing just rip apart. All right. Now we get to see our first indicator of how clean this engine really is. That is really clean. All right, so this is going to leave a mess, but here's the baffling I was talking about inside here. So the bulletin initially called for some sort of issue with sealing, but let me tell you, inside this camshaft cover right here, that PCV, that can leak. So oil consumption is possible with all. Now, granted, the LM2s had a bit of an oil consumption concern. The LZ0s started off with a bit of a concern, but then it kind of died off. But still, here and there, they do happen. But we're sticking with LM2 right now. Let's check out this gasket. Wow, this is not crusty at all. Typically, you'd find these really hard. They'll break as you're pulling up on them. Not the case here. This one is very pliable. This is our camshaft here. So this is our intake camshaft and exhaust camshaft. We can now see the timing gears. We'll line this up so that way it's timed so we can look at it. This is the old style reluctor. There is a new style reluctor that's way beefier. These will actually bend super easy. So if you're doing that camshaft cover inside the vehicle, pulling it up, there's a chance you actually bend this. It's very easy to bend it. In fact, we have nothing to lose. So let me just go ahead and bend one of these and kind of show you. Let's just go in here. See? Just like that, we now have a bent one. Now you could have timing codes and other issues. So super flimsy design, but they did upgrade that. That was roughly 21 where that upgrade came into place. All right, I want to rotate this engine so I can get these timing lines lined up here. And so we can kind of see the timing situation. Right now, I have those lined up, the camshafts, but that's not going to tell us the whole story. What we need to do is there's a guide pin that needs to go in there. All right, so what I did was I lined up the timing mark here in the front of the engine. That means number one piston is at TDC all the way up. Therefore, everything should line up back here. Now, when I go to the timing marks back here, you can actually see that they're off. All right, so with that lined up, we actually look down here and we can see the timing marks are not perfectly in line. Now, there's one more tool that would go right here to verify the location of this. It locks into place on there. I don't have that with me, but we're not going deep into the timing of this because I have a full breakdown video of that. This one we're just kind of showing all this assembly. All right, so let's say I wanted to replace the high pressure fuel pump. Now we need to pull off this cover. There is a special tool. The seal is a one-time use seal as well. There we go. So this O-ring is a one-time use O-ring. I have never seen this O-ring leak, just an FYI. Very good seal. But now you can see the actual pump. We need to get that bolt off. However, you don't want to lose timing because this injection pump is timed. So what we want to do is set up the lock tool in order to hold it into place. And that lock tool is right here. So we go ahead and get that lined up. So that's held in place because I already set this at TDC number one. So this may need to be rotated in order to get that in there, but now we're going to reuse those bolts that were there. And this is going to hold this into place. By hold this into place, I mean it's going to hold the actual gear into place so we don't lose time at all. All right, so now that's going to hold that there. We can go ahead and take off that bolt. It is suggested that you use a hand tool. It is an 18. So we can do. There is a keyway on the new pump. You can see it was Loctited with green. That's not going anywhere. So we'll set that up there. We need to get the pump unbolted. 13mm bolts. As you can see, there's 3 of them. So this is where the tool comes into play. We need to screw this in. Doesn't need to be super tight, but snug it down, it stops. And then we need to screw that in order to press that pump off. We will do this by hand, so that way it's proper technique per se. But this is going to just pop, and there it went right there. And so you can see the pump is actually able to be moved now, and we're pressing it off slowly. If you do this with a gun, there's high risk of issue, and that's going to come off just like that. Now let me go to the keyway for you. You can see the keyway right there. Hopefully you can see the keyway. Now let's talk about this pump. This is a HP5 fuel pump, high pressure fuel pump. You can see, oh, just made it worse. HP5D. So these do not have failures like you would think with the CP4s. Remember, that's all over the internet, so a lot of people worry, is this the same pump? Because it looks similar, but it's not. So these pumps typically do not fail. I'm not saying it's impossible, but they typically do not. The issues come from the actual pump inside the tank. Now, what starts to happen is you'll see brass shavings inside the fuel filter housing, and that's usually an indicator that the pump in the tank is starting to go. Now, if those shavings make it through the fuel system, that will grenade this high pressure fuel pump. So now that we've got this off, you take the new one and then you'll want to put this new one back on. Now you need to time it so that way the keyway goes back on appropriately. And to do that, we need to pull our tool off first. And that's why you didn't want this too tight, because you don't want to have to jar everything around too much. Get all the tools all nasty, but there we go. All right, see that keyway in there? That can wear. We really need to pay very close attention to that keyway. Let me see if it helps. There we go. See it? So now the new pump will have to be lined up to that just perfect and then tightened into place. So I'm going to go ahead and put this pump back in. That way we could do the timing chain from the backside, so that way we can see that all together as one. All right, there we go. Now the pump is back in. Here is where we will put the new bolt inside there, tighten it down. In our case, we're going to use the old bolt. Get our special lock tool off. And now hopefully the timing stayed the same and there are no further issues. But what we can do now is go ahead and take off this whole rear cover. We're going to take off the flex plate first. I do want to point out there are markings on this already. So I didn't see it in the history, but again, this might have been replaced because typically you don't see markings like this. I want to give a little tech tip here, and let's also discuss cracks. Set those bolts up there. So you can see this is like a oval shape where everyone else is a circle. So you want to start with the oval one. So when installing, you want to start with the oval right there like that, so to the converter. So that will get this lined up just right. If you get one of these installed into the converter and tighten it down, as it comes around, it's going to be tighter and tighter and tighter, and you're not going to be able to get the oval in. Always start with the oval, and that will allow you to tighten this. So now, we're looking at this, looking for cracks. These can crack. It's not extremely common, but they do happen. You'll get cracks up here, you'll get cracks. So this one actually looks really good, and we're gonna leave this alone. Look how clean this looks. So we're gonna go ahead and take off all of these 8mm bolts, and then there's gonna be some plugs back here that will look for leakage. Now the early years, There was an issue, and I believe it was a casting issue with this cover itself, where the seal would actually get cockeyed and it would blow oil out. I mean, dump oil out. Not just a small leak like this, but dumping oil out. So that would get a new housing. I suggest you get a new housing anytime this comes off. Nobody wants to clean that and reseal it and hope that it works out. So always get a new housing. It does come with a cheap tool that allows you to install the rear main seal properly. There is a GM special tool that works better. Both of them do the job, but we're gonna go ahead and take off all of these 8mm. And we're gonna pry this off and we're gonna look back there. All right, so pry point, a good pry point for me is right here. It's slowly walking around. I'm going slow. Don't put your finger back here. All right, so we have nothing to lose. We were able to do that. There we go. All right, so now we can remove this and voila, look at that. The oil pump belt, the dreaded oil pump belt that everybody hates. Let's talk about the oil pump belt real quick. All right, this is the oil pump belt. Obviously, it drives from the crankshaft to the engine oil pump, where this is a wear item. I will tell you, there's a lot of people freaking out about this. Since this engine came out in 2020, I have not seen one failure from the engine oil pump belt. The maintenance interval of it is 150,000 miles for the 2020, 2021, and 2022. However, in 2023, they upped that mileage to 200,000 miles. So no change to the belt. They just found that it was working out a little bit better than they had anticipated. And so they upped the maintenance interval. So in order to get to this belt, as you can see, we had to remove that rear cover. To get to the rear cover, you have to remove the transmission. So there's a lot of concern about that, the high cost. It's a couple $1,000s, honestly. So the transmission just needs to be unbolted, pulled back, remove this cover, put on a new cover with a new belt, reset the indicator inside the cabin and or on the dash, the IPC, and you're good to go. But don't worry about this oil pump belt. I know people freak out about this. Honestly, these timing chains are much scarier than the oil pump belt. But let's go ahead and get into getting this off, which is just take off this 13mm and it comes right off. All right, let's talk about potential oil leaks here on the back side. Obviously, this rear cover could be a leakage point, and when installing the new cover, this has to be absolutely perfectly clean. No need to over sealant it. It seals up pretty well. This is an important point right here. You want to make sure that you actually get all of the oil out. See how it's all built up right here? If that starts to creep in when you go to seal it up, it's going to cause issues. Now the other thing is these plugs, just like up in the front of the engine, those can have a leak point. Now this one obviously gets covered up by that cover a little bit, and this one does not. So these are two different sizes. Do not mix these up. These are sealed up the same way as the front one. In my case, I use GMS or the regular sealant, the PTFE sealant, but you can see how short this one is. And there we go. See how long this one is? You do not want to mix these two up. It's going to cause you issues if you do. So the long one goes on the bottom, the short one goes up on top. We're going to go ahead and just set those back into place so I don't misplace them or kick them around. And then we'll get to the oil pump belt. All right, so for the oil pump belt, take this off. It's a little 13mm bolt, and then this just slides right off, and that disconnects it from the oil pump. There is no timing of this at all. This just slips into place. You can look closer into here to look for wear. I've never seen wear in there. There have been some reports that they've seen wear. I've never seen it. So then looking at the belt, the condition of it, obviously you never want to bend a belt back like this that you're ever going to use again. But right now we're looking for any cracks or anything. There's no signs of issue with this belt at all. And like I said, 100,000 miles. So it's not at the end of its life. Still got a good amount left, but I can see why they bumped it to 200,000. I bet they go even further. They're just protecting themselves on that. So we're going to go and set this aside. Let's work on taking off this upper cover and we'll show how that's sealed up in there. Just 8mm bolts on those again. You want to be really careful when prying because you don't want to damage anything. So definitely don't pry on your reluctor. I highly advise you not to pry on that bolt like I'm about to do right now. And there's our cover off, and we can see more of the secondary timing chain. You heard me say secondary timing chain. This is the primary timing chain, and this is the secondary timing chain. The secondary is the one that got revised into a newer, updated version with holes inside of it. I have a whole video on that, so be sure to check that out. Let's go ahead and take out the tensioner here, and then we'll just start to disassemble the timing chains, and then we'll work on the cylinder head. Then we'll roll it over. This is a 18 millimeter. Go ahead and back that off. See the oil coming out. It is pressurized by engine oil. Here's a closer look. All right, we'll go ahead and start with getting this undone. This is our guide, so we can go ahead and look at that for any abnormal wear. None noted. Actually looks really good. Go ahead and just take this off now, because the timing isn't absolutely critical for us at this point. That is the primary timing chain tensioner right there. And so that does take a little lock tab or tool that goes in there, but when you get a new one, if you're doing timing chains, I suggest you get all new parts. But like I said, these guides actually don't show much wear at all so far. Looking at this one, we can see a mark, but it's not like grooved in that I'm seeing on it. We'll go ahead and take off this Allen. This is an 8 millimeter Allen. Take this Allen off. This actually passes through both guides. See, we got all that blue Loctite on there, but that just passes through, and that holds the guide there for that tensioner. We probably should have done these 15s first, but that's okay. So I'll go ahead and do those 15s now. Just in disassembly mode. These are the exact same as well. But now you're probably wondering, well, they're free spinning, so how do they lock in place? This one doesn't really matter which way it goes. It's the reluctor. So you want the cams, there's a full tool that goes up here and it locks this cam, both of these cams, into place. So that way these cams are dead on straight up, and then you lock the crank dead on straight up. So you know your cams are good and the crank is good. And these are just to allow the rotation of the camshafts. And this one, this reluctor, is to allow it to read properly. That's why this has to be timed with that special tool that locks in there. I'm not seeing anything on the guide specifically. So again, that one's good to go. We can get this chain out. So this is a solid chain here as far as there's no holes inside. That's the updated variation, has the holes inside. And that allows for better oiling, and it'll extend the life. And I don't know, but I assume the metal is actually a little bit more improved on the newer ones. But again, that was 2020 only that has this bad design chain right here. I call it bad design because it's unfortunate that it happens in the 2020s. Like I said, this only has 101,000 miles on this engine, and we're really close. We're getting close to pulling pistons. This is the cam carrier, and this comes off as a complete unit. So what I highly suggest anytime you're taking this off is to actually loosen these all by hand. These are all 8 millimeter. You don't need to take off the caps themselves. We will take those off in order to look inside, but you just want to get the perimeter bolts. The best way to do it is to unbolt the outer, and I'm doing it incorrectly, and it's just because I'm just tearing down. We're not going to reuse this, but we might as well do it properly, right? So you just want to Hopefully we don't drip. All right, now these are all the rockers. Very nice rollers. I'm not seeing any kind of abnormal wear on any of these at all. So we can go ahead and take those off one by one. And they have the followers with it, these lifters. So we can go ahead and pull all of those out because we will be taking the cylinder head off, looking at the valve springs, looking for any kind of discoloration. I'm not seeing anything. We'll go and get all of these off. These do have very large needle bearings inside. It's a very robust setup. All right, obviously I cleaned those up a little bit so we can take a look inside here and see. This is where the fuel injectors were going down into. You can see where all the bolts were to hold that down. Now let's go ahead and get these. I think these are 18mm bolts. Not looking forward to this. Sometimes we gotta get creative if we're gonna pull off the head bolts, and I struggled with getting those loose, obviously. So here's what I have. I do not recommend this to anybody, but I have the cherry picker actually holding up this portion of the engine, so that way it's lifting up while I torque down here. Giant, that was from my jack actually. So we're gonna go ahead and start to rip these off. All right, so we got some 10s. Those 3. Obviously no issues noted with it, but we didn't have an issue. So you can see the little bit of dirt in there. Remember what I told you about that, the fuel injectors. They could drop some dirt in there. So I'm just trying to get it off of the dowels right now. Working one-handed. It was a little tough, but just trying to peel it off little by little. All right, once we got that started, it should just, let's see, it's stuck pretty darn good. There's our first look at the pistons. Let me get a better light going here so we can see this a little bit closer. All right, what I don't want to do is induce any extra damage to the cylinder walls because of the dirt. So I'm going to go ahead and blow this out before we do anything. Clean all this off as good as I can. Without rotating the engine, we're just going to go ahead and take a look here with the camera, see what we can see. See the crosshatch, if it's worn away, any grooves, any signs of wear with the pistons where they're at. Obviously, we haven't pulled any pistons out yet. This is just an early look. This one's going to give us the best look. Honestly, preliminary inspections, I'm not seeing anything. So that one's got some odd spotting to it. And then it's a little bit cleaner. This one you can see the injector spray pattern a little bit. And obviously I wiped that one and that one and that one and that one. But when they're wiped, you can see the spray pattern cleaned up a bit. There's no change to the bowl shape. The LZ0 has a different bowl shape. But again, this is an LM2. So be sure to compare that when I do the LZ0 teardown video. But this is where we're at. So we're going to rotate this over and we're going to get this pan off. I still haven't got that chain off, I guess. I should probably finish getting that off, and we'll do that. And then we'll roll this over, get that pan off, get these pistons out, and see where we're at with this wear. All right, so since we already pulled that off with the puller, it shouldn't be that difficult. But we could use a 3-jaw puller. We could also tap it with a hammer. Lots of options on this, but I suggest you use the tool itself. So we'll just thread this in place. And there we go. It's popped off, so now we can take this gear off. This guide comes out. A closer look at the gear for the injection pump, the high pressure pump. You can see There's really not much wear shown on here, but you should really always inspect to be up like that. Now, there have been instances out there, not to me personally, but I've heard about them, where that guide actually is worn down and it causes the pump to be out of time, and being out of time is a huge issue. So it's very important to have this properly set in there. Now, it is advised to just get a new one anytime you take the pump off, just because that could be damaged at any point in time. So just throwing that out there. And then you can see the pump gear where it's going to slide on for the gear right there. It's pretty stout on the pump. It's minimal on the gear itself. Let's take a closer look at the guides here. 100,000 miles. And I would say the wear is absolutely minimal. If you're going to do timing chains, highly advised do all new timing chain guides. Even though these ones don't show bad, if you're gonna go through all that work, like, give it the best fighting chance to stay good. So the guides were not the cause of it. The tensioner was tight. This is a one-time use seal. The sensor itself can be reused, but the seal needs to be replaced. And there is our chain. You can see the holes in this one. Good, robust design. It's much thicker. I bet if it was as thick, if the top one was this thick, we wouldn't have any timing chain issues. But the holes are there to allow oil to go inside the chain, which will increase its durability, and granted, much larger chain links in comparison to the secondary chain. So there we go. We can now rotate this over, take off the oil pan, get these pistons out. We're gonna go ahead and take off the lower engine oil pan. That's going to give us access to the lower crankcase extension. So I'm gonna take off the lower oil pan. You can see by this bolt being different right here, that means somebody had been in here, but we already knew that, and it happens. These are super small bolts. They get lost, I get it. No problem there, as long as they put it back in, is my opinion. That one wasn't even tight. That one wasn't tight. When I'm going to get this off, it's going to be quite a fight. As long as they cleaned it, which I believe they did, because that stuck pretty well. I'm going to get the pry bar on it, and we're going to try to pry off from different points. This one's a good access point right there. Unknown what kind of mess we're about to make. Really hoping for the best. So you want to do everything you can to not damage the sealing surface. Remember that. Peel right off, and hopefully don't make a giant mess. All right, so like I said, this was replaced at 50,000 miles. And this actually, there's not much debris in here for 50,000 miles. The initial 50,000 miles, you'll get buildup down here. There's a lot of like crusty. So you'll see more than this in the early stages. I think that that's partially the belt wearing in a little bit, and just whatever else that builds up down on the bottom. But that's not a great thing by any means, but it's not causing any harm. We're going to see the engine oil pump right here. This is the pickup tube, so we want to look at the screen, see if there's anything in there. I don't see anything in there. Look at all this oil. That's going to make a big mess. The solenoid was replaced at 50,000 miles. That's why that pan was off. That does happen. We're going to pull off the solenoid, see if there's any debris in there. But you can see how the pump goes through right here, and that's how the pump is turned. But right there's the Allen bolts that are holding this lower crankcase extension in place. This wire is the one that's on the outside of the pan. Now, if you notice, there's no level sensor in here at all. So these do not have a notification if you're low on engine oil. So that's why it's imperative that you check your engine oil level regularly and make sure that you're okay. I also want to point out this right here. Now, yes, this is your oil filter adapter, but this is also the bypass valve. This is built in to the engine block here. This is removable, but you'll notice engine oil filters, some have a bypass valve, some do not, if you read deep into the specifics of it. Now, that's okay because there's one built into the block, so you can go either or. There's not a problem having a bypass valve built into the engine oil filter as well as the engine block in this case. So in case you didn't know, we're gonna go ahead and start pulling off this. Let's do the engine oil cooler. We're gonna unbolt this, get that off of there, and then we'll unbolt the oil pump and we'll take a look at the screen on the solenoid. All right, so that is a T30 for the solenoid. I don't see any kind of debris on the screen. We'll set that there, let that drain for a few moments. Spins very freely. That's great. There's no binding at all. It's a nice bearing inside there. You'll want to look inside here for any kind of wear on those teeth, but that is all good. Let's go ahead and take off this oil cooler like I said that we would. Made a big mess, as expected, but unwanted. Engine oil cooler seal here. These are one-time use. You see how these get a little smashed up like that during installation. Luckily, this one didn't leak, but that's usually what will cause a leak right there. So these are one-time use seals. Maybe doing this in the garage wasn't the greatest of ideas. I prepared for the worst, and I've accepted the worst that's going to happen. Now you're probably wondering, why aren't you just rotating this all the way down so it's directly straight up and down? Well, I'm going to be unbolting the pistons, and I want to be able to have full control so I can unbolt and then reach around and grab. Obviously you could do that too, but I just don't want the pistons to slide out and just fall straight down, which likely won't happen, but this is what we're doing here. So we're going to remove this lower crankcase extension. Now this is just held on by some 10mm bolts around the perimeter, and then we've got 8mm hex head Allens that we're going to pull off down the center. So then we're going to be able to pry that off, and then we will see the crankshaft, and from there we can actually unbolt the connecting rods and pull those pistons out and see what this block looks like. All right, now we'll get the Allens. All right, so I believe I got all the bolts. I think we're about to find out. All right, game plan is to go here. There is one seal on the lower crankcase that is a one-time use, GMS silicone one-time use. You can see how much squeezed out right there is a good amount of sealant on there. They call for 4mm of sealant on the lower crankcase. All right, well, the goal was to see how much wear there was at 100,000 miles, and we are about to find out. All we gotta do is just get these connecting rod caps off, pop the pistons through, and we get to see what we're working with. All right, so the game plan here is take off the caps, keep them in order. Now I'm setting them all down exactly as they came out. And now that was 6, 5, here's 4. I will say this engine spins over very, very easily. And that is a great sign as long as my pistons don't fall out. Just a little bit of a carbon ridge over there that's just holding these in. All right, I'm just going to use the back of a hammer There we go. There's our piston number 6. Really don't see much wear at all on the side skirts. I'm going to set this down. We'll knock out the rest of them and we'll go ahead and see what we got. Here's number 5. And 4. Three. There's 2. And 1 came out the easiest. All right, from the underside, we're looking. Look how freely this crank spins. Let's go and take a look at crank surface here. At the connecting rod, you can see that there is a little bit of wear showing. Let's take a look at this one. Let's get a nice clean one and go through it again. We've got all 6 pistons here. This is cylinder number 1. I'm going to go ahead and clean this off so we can have a better look at the skirt itself, just to see if there was any abnormal wear, just how much wear we do have. There's very little wear to the actual skirt itself. I think this is in very good shape. 100,000 miles. Looking at the rings, the oil control rings are not seized at all. We can see a little bit of oil up here burning off. That second ring is sticking in there. Top ring is free to spin, so that is a notable that the second ring is solid. It's not moving. So we did have a little something going on there. Let's go ahead and check the other ones. Number 2 has a little bit more wear on the skirt. You can see on the upper portion, so there's a little bit more movement inside there. Yeah, definitely a difference between 1 and 2 in terms of wear showing. Looking at those 2, but let's see here. The oil rings are free spinning. Second ring is also not moving very well. Let's see if I can free it up. I mean, half of it is not. There's a little bit of contamination in here. I can feel this roughness. So there is something getting into this cylinder number 2. And that's what we saw on the glow plug as well. That's burned and I can feel the rough surface of it. Let's see if that's on any of the other pistons. You see a little bit there. What that is exactly, I couldn't tell you. But anything is possible at this point in time. We did not notice any coolant loss or anything of that nature. Oil control ring is not seized on this one either. Second ring is locked up. Seems to be par for the course. We can see more of this residue on the top of that piston. That's number 3, and we did see that on the glow plug as well. Number 4 has none of that. So whatever that is that's building up in it. Let me clean this off. So we have some wear. Not much at all. These pistons really look really good. See the rings. Oil control ring is a little tough to move on this one, but we probably damaged it. There we go. It's free to move. It was tough because it knocked it out of place. The second ring locked up on this one too. All right, number 5 piston. It's looking good. Yep, I think we're looking pretty good. This one has a little bit of that residue as well. Again, I'm not sure what it is. Comments, feel free. and we can discuss it. But second ring locked up, top ring free spinning, and the last piston. This was the one where somebody actually commented when I asked, hey, what kind of questions you guys had. They were concerned about the back cylinder showing any extra heat or anything of that sort. So here we are, number 6. Second ring is completely locked up. It's not going anywhere. Top ring is good to go, but none of that residue up here. No signs of any deforming of the piston bowl itself. Let's take a look at the bearing. I'll clean these up and we'll look at each of the bearings. All right, number 6 bearing. We do show some wear. We've got the coating has been worn off. We don't have any copper. No signs of copper in that. Again, coating has worn off. So we have wear showing, nothing horrible. If we saw copper, we would know that we have an issue. But yeah, like I said, there's somewhere on the coating is gone. But you can see the aluminum. Like I said, no copper. So we haven't worn the bearings down. So the bearings do show wear. The second rings are locked up in the majority of these. Oil control rings in good shape. Side skirts looking good. Cylinder walls on the engine. All right, this is cylinder 6. Cylinder 5. And cylinder 4. Cylinder 3. Cylinder 2. And cylinder 1. So there's 1, 2, 3, 4, 5, and 6. This is cylinder 6, cylinder 5, 4, 3, cylinder 2, and cylinder 1. You can see the way the block is designed. Coolant to pass through there. That helps keep the cylinders cool. It's excellent. This block is actually very, very unique. I like the design of it. I think the overall, we don't have head gasket issues with these engines. The cylinder heads are stout. The block is stout. This engine is honestly a very reliable engine outside of the timing chains and a few other things that I pointed out here. Looking great. I mean, we can still see the crosshatch. So I would say this engine was in good shape at 100,000 miles. We're gonna go ahead and flip it over and we'll take a look at those crank bearings real quick. I see nothing wrong with this main cap, which is the 7th cap. And I also see nothing wrong with the crank itself. I mean, just absolutely perfect shape on that one. Here we've got number 6. And again, I see nothing wrong with this at all. That's just looking really good, to be honest with you. All right, so this is our 2, 3, 4, 5th one here. 5th one in. Again, see nothing wrong with this one. Crankshaft looks amazing. Once again, Nothing wrong here, nothing to see. Definitely looking great. There was somewhere on the connecting rod area of the crank. I mean, nothing to like be worried about, but just pointing out little things, since at this point we have so many good parts in such good shape. So again, same situation here, and we're coming down to the final two. This one actually has some damage to it, so something got in there, and it actually, we were starting to have some issues. So you could see that it kind of ground in on that one, and the mark is also in the crankshaft over here. So this one had something go through it. So that was our only one where we actually saw something. This one right here is looking really good. There is a little bit of shininess on the front side, but nothing to really be concerned about. I mean, these bearings look fantastic. This one had a little something go through it. Sitting pretty good. What I'm going to do is bolt all this back together, and then when I get the head on here, I'll go ahead and pull the cams apart, and we'll look at the actual camshafts, see how those are looking, if there's any wear like this up top. But on the bottom end, I think the bottom end is pretty stout. We had some ring issues on those. Overall, I think this was looking like it was in good shape. This one right here was a worry. So I think this consumer here made the right call as far as replacing the engine. They spent all the money on the timing chains and everything, and then 50,000 miles, that bearing went south. I mean, probably even less than that. Once it starts to go, it's going to start to go. But they definitely, I believe they made the right call for sure. So I'm going to go ahead and button this bottom up well enough so that way we could spin it over and get the head on there and get this camshaft apart. But let me know what you're thinking so far as this goes with this 100,000 mile engine here. All right, so looking closer at the cylinder head itself, not seeing any issue whatsoever, looking for any kind of cracks or anything. I did a basic wipe down, but I do want to note all the crap that's inside of the fuel injector holes. That's always a risk when you pull out the injectors. You're going to drop that in there, and it does look like a bunch of rust and whatnot. So that is a worry, as when you pull the injectors out, you are supposed to clean those out. But again, it's just going to go inside the cylinder. So my advice would be, hopefully you never really have to do an injector, because potentially that dirt will be falling in there. There's the underside of the cylinder head. Really nothing notable to note on it. Looking down inside, let me get the light again, see if we can see inside. These valves a little bit better this time around. So these are the intake valves. And this is the back of the head. So this is cylinder number 6. Again, like we saw before, the cylinder number 6 seems to take on less oil. But they don't look too bad. Let's take a closer look at the cam caps. Looks like we got a little bit of wear showing there. Minimal, looks good. This one's got some scoring in there. Let's take a look at the cam itself. Looks nice, nice and shiny. We're looking for real good shininess to it. Any signs of different shades of shininess is really what we're looking for as far as anything concerning. So far all of these caps show like a very minor amount of wear, which is going to happen. I mean, there's no way around it, but there's nothing like abnormal. This one has a little bit of darkness, but still, otherwise I would deem those in good shape. So we can see a little bit there as well. This one's got more. So the exhaust side camshaft shows a little bit more wear. Let's take a look at the cam itself. Yeah, see, the cam itself is actually showing a little bit of wear as well. Just slightly more wear than the intake side. So there's a little bit going on there. The cam shows some additional wear. It's very slight. I'm just pointing out the very small differences. This cam cap probably shows the most amount of wear out of all of them so far. And on the cam side, really nothing to be seen. There's some wear too. So exhaust side towards the rear, showing a little bit more wear than all of the others were showing. Let's get a closer look here. It's really nothing significant as far as wear goes. The cam actually, or the cams appear to be doing pretty well, I would say. So I'm happy with what I see as far as wear goes for 100,000 miles. This is nothing to be concerned about in my opinion. Let me know what you think. You can see a little bit of pitting on this one and a little bit of wear. So this is the only one that's shown some wear that was noticeable enough. There's a little bit there too. Didn't catch that the first time around. You can see like some slight grooving in there, right? But that's, I mean, that's to happen. But yeah, those are still in good shape in my opinion. I wouldn't really reuse them. Like I said, don't reuse parts that you're pulling off anyway. That could be a wear item. And then the tensioner had good tension when we took it off. That was good. The seal on the crankshaft position sensor is a one-time use. So you can either replace the whole unit or replace just the seal itself. Let's do a closer look on the belt. I mean, there's really nothing, like look at the edges. Still nice and round. Fits well in the gear. Gear has nowhere. Like I said, that's not timed. It just gets bolted into place and it just free spins the pump. Here's the fuel injectors one more time. 100,000 miles on this engine. I think it was in pretty good shape for having 100,000 miles. Granted, we did find a couple little issues in there. The piston rings, that's questionable. With that being said, this engine was running good when pulled out, and I think it would have continued to run good. Now, obviously, there were a couple wear points in there, but there was nothing major. So definitely 100,000 miles. These things can handle the 100,000 miles. I heard of one guy commented on one of my videos prior that he just replaced his engine at 300,000. So long-term hope on these engines, it is there. Just take proper care and keep a check on it. And it wouldn't hurt to send out a used oil analysis every once in a while, just to kind of give you a rundown of what the engine's looking like. I've done a bunch of those on my channel, but if you're maintaining your vehicle yourself, be sure to check out the whole package of maintenance videos that I've created for this 3.0 Duramax diesel. Hopefully this helps you out somehow. Knowledge, if you're in it and you're stuck on something, you want to see something, hopefully this video provides that for you. So till next time, see ya.